Eric Burgess here. How many ways can a person select 10 books from 15 books? There's an important assumption we're going to make here too, and that is, maybe we should star this. That is star all books are different. And the reason we're doing this is because if they're not all different, then we think they would give us some sort of an indication that they aren't. So if all the books are different, we look at this and we say, okay, well, we're picking 10 books from 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say we picked like book, 12, and then book 11, and then book 3, and then book 2. We keep picking books. Well, what if we had a different order, like 11, then 12, then 3, then 2, right? So these two swapped places and on and on and on. Well, is this any different, right? Because our question is really, does order matter or not? And if it does, we pick permutation. If it doesn't, we pick combination. Well, we're just picking books. We're just selecting books. There's no indication that the order that we pick these books in is important. So we're going to go with order does not matter. The fact is that we will end up with the same 10 books. There's nothing about here that says, oh, the order of the books is important. So we're going to go with combination. We're going to treat these as not different. So because of that, we're going to choose NCR, and it's a good habit to always write out the formula so you begin to memorize it. We're going to have n factorial, and then we take out, well, this bit's 4, right? Because we're only picking R number of items. So we've got to remove all the others. And then we have R factorial. This gets rid of all the repetitions that don't matter. It's because these we don't consider different. The R factorial takes care of that. So we're going to have, how many books do we have? We have 15 books. Remember, N is always the total number of things. And then C and R is the number of things we pick. We were picking 10. So this is equal to 15 factorial over 15 minus 10 factorial, 10 factorial. So I'm just going to go downwards in this case. So we're going to have 15 factorial over 5 factorial, 10 factorial. 15 factorial, I'm going to go over. I'm going up, down, over, left, right. Be careful. So we're going to have 15 times 14 times 13 times 12 times 11 times 10 factorial over 5 factorial, 10 factorial. 10 factorials go away. 5 factorial is really 5 times 4 times 3 times 2 times 1. 5 simplifies with 5. This becomes a 3. 4 simplifies with 12. This becomes a 3. These become 1s. 3 simplifies with 3. They both become 1s. 2 simplifies with 14. This becomes 7. And we've effectively eliminated the 5 factorial. And we're left with 3 times 7 times 13 times 11. So 3 times 7 times 13 times 11. And we're left with 3,000 in 3 ways. We can double check this by simply doing 15, go to math, go to probability, choose number 3, and then 10 for R. We enter, we see we get the exact same thing, which means we did not make any sort of weird algebra mistake. And that's how you do this problem. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we will catch you in the next problem.